Hello, geometry students. Mr. Zacek back and with you. Sometimes when I'm working on this stuff, I just need a little, want to give you a good little beat going to give you my best energy when I'm doing these videos here. We're working on Geometry Midterm Review 3, and we're going to work our way through this one. And hopefully just help you clarify how things need to be done and what needs to happen and all those good things. So write the equation of the perpendicular bisector of DE with those points that are given to us. Okay, so I'm going to look at this a couple ways, but we've done a lot of these. Some people are still unsure at times, so we want to think about this thing with, we're going to start off by finding the slope. And we're either going to get the slope from the points or from an equation. If the situation is points, then we're going to do the slope formula. y2 minus y1 over x2 minus x1. If not, we're going to get it from slope-intercept form, y equals mx plus b. Okay, the bisector piece is going to be our midpoint. So there's our x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And then we're going to do the midpoint slope formula, which is y minus y1 equals m times the quantity of x minus x1, y minus y1. So our point is our x1, y1, x2, y2. So let's go ahead and do this. Now I want you to write out the slope of DE. It's going to be y2 minus y1 over x2 minus x1. You want to be a little careful with your negative signs. Put that second one in parentheses. So the slope of DE is going to be, that would be 2 over 6, which would reduce to be 1/3. If you put that in your calculator, it will simplify it for you. So I'm going to find the midpoint now of that, and so that's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Midpoint formula, that's for you. You have to add and divide by 2. So this is going to become negative 2 over 2, which is negative 1, and then we have 7. 14 divided by 2 is 7. So we're trying to write the equation of the perpendicular. So when we see perpendicular, we should think negative reciprocal slope. So our perpendicular slope, or our perpendicular m, is going to be negative 3 over 1. I take this 1/3, I flip the sign, or switch the sign and flip the fraction. Okay, and then our point, negative 1, 7, that's going to be our x1, y1 for our point slope formula. So y minus y1 equals m times the quantity of x minus x1. This is, I call it the cleanup step. We do x plus 1. Okay, and that right there is an acceptable answer to this question. We don't have to go ahead and carry it further, although we could by distributing negative 3x minus 3, and when we add 7 over to the other side, it would be plus 4. So if they said write it in slope-intercept form, we could do that as well. All right, so definitely are going to see some questions like that. Hopefully that gives you kind of a good overview of what you need to know for those questions. All right, number 2. This is one where we need to recognize that this is an exterior angle, and these two over here, the language for these are called remote interior angles. And if you think of it, a remote is something that we use to connect with something that is far away from us. So this over here is in what we would call an adjacent interior angle. So the exterior angle theorem for triangles says that 5x minus 40 equals the sum of the two remote interior angles. So it's going to equal 2x plus x plus 20. Okay, so that relationship, we want to see the exterior angle equals the sum of the two remote interior angles. And now it's just an algebra question once we recognize that relationship. Okay, so we would subtract 3x, add 40, and that would give us 2x equals 60, so x would be 30. And again, you could go and do a whole bunch of other things with that. Finding angles, plug things back in, etc., etc. All right, what are the properties of the mid-segment of a triangle? So let's think about what is a mid-segment. A mid-segment is a segment that connects the midpoints. So that would be what it looks like. So a mid-segment is half the length of the opposite side and it's parallel. So half the length and parallel. So when you get that parallel, you want to think congruent angles. So like those would be corresponding angles, those would be corresponding angles. All right. So we want to recognize a mid-segment of a triangle. Now let's just note this because it's not a median. A median, the definition of a median is vertex to midpoint. Whereas a mid-segment is just connecting the midpoints like we see in the diagram up here. Okay, so orthocenter. Now we got our points of concurrency. In a triangle we have 3 lines and we need to know where they come together. It's the point where they meet called concurrency, where the 3 lines come together. Orthocenter, it's the intersection of the altitudes. Okay, AB is in, the in center is the angle bisectors. Okay, the circumcenter is the perpendicular bisectors, and the centroid is the medians. Okay, centroid, that's the one that's in the ratio of 2 to 1. Okay, so for me, the saying that I have, this is a little bit out of order of my saying, but I do PB, CC, perpendicular bisectors meet at the circumcenter. PB, CC, 2E. So you notice here that the centroid and the medians both have the second letter of the. All right, for the orthocenter, I think of double T. Both of those words have 2 T's in them. And AB is in. So that's how I remember it. PB, CC, 2E, double T, AB is in. 2E, double T, AB is in. PB, boom, 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 CC, boom, 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 PB, boom, 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 CC. 2E, double T, AB is in. 2E, double T, AB is in. Whoop, 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 whoop. Okay. All right, so we've got, oh, that was fun. We've got our altitudes. Let's do angle bisectors. I'm not going to construct these. I'm just going to sketch them. Circumcenter, and let's get ourselves a centroid over here. So altitudes, perpendicular. So it has to form a right angle. Okay, so there's an altitude. There's an altitude. Just remember that that can happen with the altitude or the orthocenter. It could be in, on, or out. The in center is going to be the intersection of the angle bisectors. So you're looking for, in this case, we're going to look for some tick marks that tell us that those angles are congruent. Okay. And over here we would again see, okay, some tick marks telling us there. All right, that's always going to be inside, and that makes a circle on the inside of it, the inscribed circle. the perpendicular bisector does not necessarily have to come out of the vertex. That's the only one that doesn't have to come out of the vertex, but it's going to be perpendicular, form a right angle, bisector, go through those two sides. Over here, let's see if I can try to make this look halfway decent. Trying to make it look like it forms a right angle there. I don't know how well I'm doing. So perpendicular, bisector, that's the circumcenter. Okay, the circumcenter can be in, on, or out. Again, it's in when it's acute triangle, it's on when it's a right triangle, and it's out when it's an obtuse triangle. Okay, the medians are going to come down from the vertex to the midpoint of the opposite side. Obviously, I could draw the third one, but I'm just doing two. So, all right, and that's the centroid. And the centroid, the center of gravity will always be inside, and you want to think of that as the length from the vertex to the centroid is twice the length as the centroid to the midpoint. Okay, so just, there's some vocabulary, there's some relationships. This is one of these things that, you got to spend a little time, and hopefully, you've kind of got a system down for how you remember those things. Okay, construct a 45-degree angle. Now that is not a direct angle, so I want to think that 45 is half of 90, which means I'm going to do an angle bisector construction. So I'm going to start off here, and I'm going to just have some kind of segment. And then with that segment, what I'm going to do is I'm going to, I'm gonna bisect it. So I'm gonna do the perpendicular bisector, which is our surfboard one. Okay, above and below. Bring it over. Above and below. You don't need the full surfboard. You can just do the intersections at the top and the bottom. So what did we do? We created a 90-degree angle. Now what I'm going to do is I'm going to take one of those 90-degree angles, it doesn't really matter which one, and I'm going to construct an angle bisector. So remember, with our angle bisector construction, let's just do this in a different color to illustrate the differences. With our angle bisector construction, you want to start with a reference arc, hits both sides of that 90-degree angle. Okay, I'm going to come up here. Let me turn this a little bit to make this work. Okay, there we go. Come on down. All right, and now I'm going to connect from the vertex of the 90-degree angle through the angle bisector, and we have just created two 45-degree angles. Okay, so we always want to think kind of creatively as we're doing these. So we want to construct a 60-degree angle. So we want to think this is an equilateral triangle. We've done this in a couple of our other reviews. So again, what we're going to do, if we're given a segment, we would use that, but we're not. So we'll just create some segment. We'll draw it, use our straight edge. Okay, and we're going to go and we'll measure with our compass. So we come out here and we measure that side, and we come over to the other side. Whoops, I adjusted it, so I'm going to go back and re-get it out to this side. And we're going to come up here now, and at this point we've got an equilateral triangle. So we want to take our straight edge and we're going to connect these sides, and we've in effect, what we've done is we've got a 60-degree angle. So if we want to take that now and turn that into a 30, 60, 90 triangle, the way to do that is you can either think of this as doing the angle bisector or doing a perpendicular bisector. Either one will work. So if I did the angle bisector, come down here, whoops, over here, so I'm just repeating that angle bisector construction at this point. Come down here, okay. So what did I do? I bisected a 60-degree angle, so we had a 60. I cut the 60 in half, which gave me a 30, which means what's left is a 90. And it will be the same on both sides, okay? So, some fun different constructions that require us to think a little creatively. You can anticipate one of those on your midterm. All right, now for the parallel one, I'm gonna do this proof here. There's a shortcut to do it. I'm gonna do it the long way just to review some of these things that we have here with us. So our statements and our reasons. We're going to start obviously given that line L is parallel to line M. Okay, and what I know is that 3 and 2 are corresponding angles and 1 and 3 are congruent vertical angles. So the way that I would go about this, I'd say angle 1 is congruent to angle 3. If two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. All right, so we've got those, and then we would do angle 3 is congruent to angle 2, and that is if two lines are cut by a transversal and parallel, then corresponding angles are congruent. And so then in the last step we could say that angle 1 is congruent to angle 2 by the transitive property or by substitution. All right. Now the shortcut is just go ahead and say angle 1 is congruent to angle 2 because if two lines are cut by a transversal and parallel, then alternate exterior angles are congruent. Okay. So remember, just to review, because sometimes corresponding angles are, that one's a little tricky for people to remember. So corresponding angles, we've got interior angles in here. That means these are exterior. Okay, so with corresponding angles, they're on the same side of the transversal, and one is an interior angle and one is an exterior angle. So we've got one interior, one exterior, they're on the same side, and like we've talked about earlier, that one of the angles has to come from this group and one of the angles always has to come from this group down here. So that's why 3 and 2 are corresponding, if you're having some trouble with that. Okay, I think we've got a couple more, maybe 3 more proofs. Let me just get it. Yeah, 3 more proofs here. So let's go ahead and sort of do these and talk about how to go about this. All right, so always start with a plan, and we want to mark. You want to have, I call it marking discipline. So only mark what you're given or what you can draw from your given, and then your freebies. So we've got AB congruent to AC. We've got DA bisects BC. So DA is cutting BC into 2 congruent parts, okay? And then from our reflexive property, that's our freebie, we've got a congruent side. So what I'm looking at is those 2 triangles we can prove congruent by side, side, side. And then once that, we can say corresponding parts of congruent triangles are congruent. All right, so let's go ahead and execute that plan. So we're going to do isosceles triangle ABC with AB congruent to AC. And then we've got DA bisects BC. Okay, all right, given. So far I've only got one side congruent, that's AB congruent to AC. So second step, I'm going to say BD is congruent to DC. And the reason is it's all about this word bisect. If a segment bisects another segment, it's not cutting an angle, it's cutting a segment, then it forms two congruent segments. Or sometimes we say it divides it into two congruent segments. Okay, so that's our second. So if we're just kind of tracking along with our plan, we had a side, whoops, that was crazy, crazy pen there. Side congruent to a side congruent to a side. Okay, so step 3, we're going to use a reflexive property. So we're going to say AD is congruent to AD by the reflexive property, which is our third side congruent to a side. So that kind of gives us the clear to say the triangles are congruent. So we would say triangle ABD is congruent to triangle ACD. And so the reason here would be side, side, side congruent to side, side, side. Now, once the triangles are congruent, we can say that their corresponding parts are congruent. So angle BAD would be congruent to angle CAD. Corresponding parts of congruent triangles are congruent. So again, if you're going to use CPCTC, you have to first say that the triangles are congruent. So that has to come previous to using that as a reason. Okay, number 8. Oh, we're trying to prove parallel. So generally, when we're trying to prove parallel, we're trying to show that some angles are congruent. And in this case, it's probably going to be alternate interior angles. So let's see what we're given. We're given that DAC, this angle here, is congruent to BCA. Now let's just pause and say, why is that not enough? Why can't we just go right from there? Well, I'm trying to prove that AB is parallel to DC. And what I want you to notice is that in doing that, see where those arcs are? Well, the arc doesn't actually touch the parallel side. It touches the transversal, but not the parallel side. So that would be a reason why AD would be parallel to BC, but that's not what we're being asked to prove. So the next thing that we're given is that AD is perpendicular to DC. I'm going to call this angle 1. And CB is perpendicular to BA. I'm going to call that angle 2. And we know that those are congruent. That's the only thing we can draw from our givens. So now, what do we have for free? Well, for free, we've got a common side. So we look at this and we go, hey, what do we have? Well, that's angle, side. So that would allow us to prove the triangle's congruent. If we can prove the triangle's congruent, then we could say that angle, I'm going to name this angle 3 and angle 4. So then we could do angle 3 would be congruent to angle 4 by CPCTC. And those, angle 3 and 4, are alternate interior angles to AB and DC. That would prove that that is parallel. So let's go ahead and write this out. So we got our statements, reasons, okay. So we've got angle DAC congruent to angle BCA. We've got AD perpendicular to DC, and we've got CB perpendicular to BA. Okay, that is given. So what what I'm going to do is I'm going to go on my progression with right angles. So we're going to say angle 1 and angle 2 are right angles. So that would be, if two lines are perpendicular, then they form right angles. So then they form right angles. Okay, then we can say they're congruent. Angle 1 is congruent to angle 2. All right angles are congruent. And then we're going to do our side by the reflexive property. So AC is congruent to AC by the reflexive property. So now we're going to, we can say the triangles are congruent. So triangle ADC is congruent to, now the order of these letters matters. So if we started with A, we're going to have to start with C, B, A, and the other triangle. And the reason is angle, angle, side congruent to angle, angle, side. So at this point, what I can say now is that angle 3 is congruent to angle 4 because of corresponding parts of congruent triangles are congruent. So angle 3 and angle 4 are alternate interior angles that prove that the lines are parallel. So the final thing, now we can say that AB is parallel to DC. So it's if two lines are cut by a transversal, this is a such that one, okay, are cut by a transversal such that alternate interior angles are congruent. Don't leave out the congruent part. Alternate interior angles are congruent, then the lines are parallel. Okay. So let's just pause here for a second. When you get these questions and it's like a little bit different than what, we're not just proving a triangle congruent. The way to approach it is to ask, okay, what would I know if it was true? If AB was parallel to DC, what could I say? Well, we could say that angle 3 and angle 4 are congruent. So then the task becomes finding another pathway to go and prove that angle 3 and angle 4 in fact are congruent. All right, so last one here. We're trying to prove that AB is congruent to CD. Now these ones are perpendicular to a bunch of them. So what do we got going on? We've got BE perpendicular to AC, DF, so we got those ones. And then we've got BE congruent to DF. And now here's where it gets a little weird is I've got AF congruent to CE. Well, the problem with that is that's a little bit longer than the segment I want. So what we're going to need to do here is we're going to need to do subtraction in order to shrink this down to getting AE and FC congruent to each other. Once we do that, we can go ahead and prove the triangle is congruent by side angle side, and then these will be congruent by CP/CTC. So if this question looks familiar, it's because we did it earlier in the year. But repetition is the mother of learning, as my high school football coach taught me. So BE is congruent to AC, perpendicular. DF is perpendicular to AC. BE is congruent to DF. And AF is congruent to CE. Okay, that is given to us. So I'm going to do the angle part first. Angle 1 and angle 2 are right angles. Same thing we did before. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. Okay, and then we're going to say angle 1 is congruent to angle 2. Why? All right angles are congruent. Okay. Now, again, the problem with AF is it's not side AE, and so we want to shrink it down, and so in order to shrink it, we're going to subtract. So I'm going to say that EF is congruent to EF by the reflexive property. Because if we're going to use subtraction, we always want to start with two things that are equal or congruent to each other. So at this point, we now go ahead and say, all right, AF minus EF is congruent to CE minus EF. Or, what's left, AE would be congruent to FC. See, now we, by subtraction property, we've been able to shrink it down so that what we're doing is we're saying this side is congruent to that side, which are part of those triangles. So we can finish it by saying triangle ABE is congruent to triangle, so if we started with A, we should show CDF, and that is because of side angle side, congruent to side angle side. And now sides AB and CD are parts of those congruent triangles. So AB is congruent to CD by corresponding parts of congruent triangles are congruent. Okay, so you should anticipate seeing some of those proofs definitely on a part of your midterm exam. All right, so good luck with your review and with your upcoming exam.